What's up guys, Shawnthebro here, and today we're going to be doing a blueprint-only input system. Now, for those that don't know me, I normally do code and blueprint, but I do get quite a few requests for doing things that are blueprint-only. One thing in particular that stands out and that I get a ton of is making a blueprint-only input system. And I've gotten a few different requests from a few different people for specific input systems and different types of things that you can do. So I'm starting with this input buffer system, but I do have some changes that I'll make in future episodes for tailored art, gray crayon, and dino coaster. Great names, by the way, everyone. So I have some changes I'll be making, that way I can meet the needs of all the input systems that I've been requested to do in blueprint only. But I did want to do a generic blueprint only episode as well, because I've been asked how to do the fighting game input system in a game if it was blueprint only. There's a lot of people who are following these tutorials blueprint only as opposed to using the code. So I won't waste any more of your time. We'll get started, but I just want to explain why I was doing what I'm doing. And for those that have waited for this, thank you so much for waiting. I know it took a while to get out, but I don't normally do things blueprint only. However, again, with all you guys asking, I felt that it was definitely the right move because the input systems are, they can be very complex. So this is episode 1 of the blueprint only input system. And this can work for any series. It does not have to be for the action RPG tutorial that I am showing you here. So no worries with that. The things that I have on the screen are all worthless to you, so just ignore like the red box and everything. It has nothing to do with this input buffer. This is actually just something that I was showcasing for the Action RPG tutorial series and not something you'll need. So, the input system. Now, right now, I'm just doing it like the fighting game. So basically, I can press 2 buttons and I can perform a command. In the top left, the print string goes off, which says the action that I'm using, and then an animation plays. I also have another command that I've added. I don't have an animation for it, but I can go ahead and activate it with ABC. So yes, we're using strings to pair up with the keys. Now, we will add input types and things like that down the line. This is something I've already done in the regular input system that we have, the code and blueprint version, but we can't jump into that right away without making this a humongous episode. It would have to be absolutely, like, super long. Okay, so let's get into how we did this. Now, what I want to say before we get started, if you want to check out any of the other tutorial series or episodes that I have done, I'll go ahead and just link the entire programming list, the playlist that I've done that has all the programming episodes. You can kind of peruse through the different playlists I have and check out if you want to watch anything. We do both code and blueprint in most cases, but in some cases like this, where I feel like a blueprint-only episode is acceptable and makes sense because there's so many complications with doing this in blueprint, then we'll do it in blueprint. Alrighty, so let's get started. First things first, we need to make sure that we can pick up any input that we add, or any input that we press, and add it to an array to keep track of it. So I have in Edit, Project Settings, Input, I have an action mapping called Add Input to Buffer, and I've put any key to it. So basically, anytime we press a key, and technically this will work with certain buttons, a lot of buttons on controllers and things like that, then this will get added to this buffer. This input action will fire anytime anything is pressed that the computer can pick up on. So once you've made that, you can go into your base character BP. This is our assassin character, or whatever you'd like to call it. I am going to set the armor color to be invisible, just for this episode. I know it was related to what we were working on in the Action RPG, just to make it a little bit neater as we're doing this stuff. Okay. Now, in your base character BP, you can go ahead and grab the event for when this button is pressed, so that you can do the logic that you want to do. And we also have released. We won't be using release today, but it can come in handy in the input buffer system. So basically, right click and type in the name of your action mapping. So mine's add input to buffer, and I've already got it, but you want the one that's under action events. Again, I already have it. And then the logic goes as followed. I have a key, and the key is what we're going to want to add eventually. But more importantly than that, we have to figure out what logic we want to occur when we press a button. So first of all, we want to remove anything in the input buffer that has been there for too long. So the way this input buffer is working, since I didn't give it all the, stuff at the start to kind of explain how it's going like I did in the fighting game tutorial. Basically, we want to press a number of keys or buttons in a particular order to perform an action. Regardless if you're going for the fighting game input buffer or if you're going for an input buffer where there's like a radial menu that pops up, at the core it's actually the same process. We can just change the time and change if we want to remove these objects and what the conditions are to do that. So in this case, whenever I press a button, I'm going to take my input buffer, loop through it, grab the timestamp, and remove it from the array if it's too old. But before we can do any of that, of course, we need the actual input buffer. So let's go over how we're going to actually map these out. I've made two structures, an f_input_info and an f_command_info. If we go into our blueprints folder, or wherever you'd like to put this, I made a logic folder, which is where I like to put structures that are made in Blueprint and data tables and things like that. We'll go into f_input_info. If you need to know how to make a new structure in Blueprint, just hit Add New, Blueprints, and Structure. You can make two of these right now if you would like. So the f_input_info, this is a structure that I made that's basically, this holds what our button presses are. So it holds the input name, so the name of the button we pressed, and the timestamp it was pressed at. That way we can check it to see if it's too old or not. That way we should know if we can remove it from the input buffer. Then I made an f_command_info, and this is basically, these are the commands that we can use. So these are the things our input buffer has to match to be able to perform that command. For example, I've got the name of the command, which was like command 1 or command 2, which is a string. And then I have inputs, which is an array of strings, and these are going to be all the keys or buttons that we have to press to be able to perform this command. And then I have a boolean has used command. And once this boolean gets set to true, then we can perform other logic, which would be basically whatever the logic is that we want to do once that command is done. In this case, I'm just playing an animation just to showcase that it works. Playing the special move 1, but I don't actually do anything else with it. Okay, so that's how I made my structures. You can keep all the actual values default. And then we're going to go ahead and make an input buffer and a command list, and you can probably imagine what these are. But it's an array of our f_input_info structures, and the command list is an array of f_command_info structures. So the two structures that we just made, they basically both get one array. To do this, you can make a new variable, hit plus variable, and then you can click the type and search for your structure, just like this. And then once you have the structure, you can go over to your details panel, assuming you still are clicked on your variable, and you can click the little object. It'll be like a pill or a cylinder next to the variable type here, and click the 9 squares. That's an array. So it's 3 by 3. And then you do the same for command list, but instead of f_input_info, I'm doing f_command_info, and make sure it's an array. Now you can compile and save this. If you compile and save, you'll be able to edit the default values in here. For the input buffer, I don't want anything default. The player should be the one pressing the buttons to determine what appears in the input buffer. But the command list, we actually do want to fill out. So, it'll have 0 by default. You can hit plus to add a new element. So add another element to the command list. You'll have index 0. Now it's got all the data that we put in the structure. Name, inputs, and has used command. Has used command should always be false until we press all the buttons to perform the command. The name, you can name whatever you want. I call it command 1 and command 2, just so it's clear. And for inputs, you can add whatever keys you want. When you press them by default on the keyboard, they are capital. So if you were trying to follow this tutorial exactly and you want to put Z and X, make sure they are capital if you expect to be able to just press those buttons on the keyboard and have this command fire. So yes, I made them Z and X, and then I have, and I added another command, went to index 1, called it command 2, and went through the inputs. You got to hit the plus to add inputs to your array here, so you can add as many as you want. Every time you do it, it might close because it's annoying. And if you want to get rid of an input, you can click the little down arrow and delete. Okay, so I have Z and X, and this one is ABC. Alright, now that we have that set up, you should kind of know what all the logic is. Or at least you should be able to understand what the logic is going forward, because we already have all the things we need. So our input buffer. Now I know we haven't added anything yet, so this will get skipped when there's nothing in the input buffer. But it's still what we have to do first, otherwise we'll be playing and performing old commands. So we're going to loop through our input buffer. You can just drag it onto the screen and get it. We're going to loop through our input buffer. We're going to break it. You can drag off of your array element and type break, and it will get you the individual variables that make up that structure. And we want to grab the timestamp variable. Then we want to get time seconds, which, as the comment says, returns time in seconds since world was brought up for play. Now, since we're going to be using the get time seconds for the timestamp, then you will always be able to use get time seconds, because it'll know what time the user had pressed the button, and then it'll know if we should get rid of it or not. I do minus 0.2, which basically is saying have 0.2 seconds passed since this happened. Is it still within that range? If it's not, we should remove it. Basically, this is just an arbitrary value I'm picking to say, have I pressed these buttons within an appropriate time? So you can do timestamp is less than. You can literally just put the less than sign, float less than float. And then this is float minus float. Bring it into a branch. If it's true that it's been there for too long, then we remove it. Now the way you get this remove node, you can drag off of the array itself. So I've added reroute nodes, but basically you drag off your input buffer. Whoops, not that. Drag off your input buffer, and you type remove, and it'll say remove item. I know it does not say that on the box, but remove item. And then you can drag the array element into it. Okay? That's the first part. Now, the rest of it is basically getting the logic into the array and checking against the command buffer to see if we've performed any commands. Alright. So after the loop is completed, you see it's not connected from remove. That's the loop body. But once this loop has completed, we continue on, and then we call this function, add input to input buffer. So I've made 3 functions. You can make them all now if you want. That way you don't have to keep making them as we go. Just click plus function, call one add input to input buffer. Basically, we're going to just be adding the new input to our array. And then check input buffer for command as another function, which of course is me checking against the items in the command list. And then lastly, I have start command, which is if a match is found between the input buffer and the command list, perform that command. Alright, so the way we do this is add input to input buffer, assuming you make this function. You can click on the function, like I have here, or you can go into your function and click on the first node here, and you'll have the details panel on the top right. It'll have inputs. You can press plus new parameter to add a parameter here, and we want to add an input info structure. It doesn't have to be an array. We just want to add one instance of it, just basically the key we just pressed. So you can just click the little drop down and search for your type, and then put the name in you want. I just made it input info. Now, there's a cool thing you can do in Unreal that you split up the logic. So if I disconnect these, this is what you will see. It will look like this. Now you can just go ahead and use this. You would need to actually get the F input info, not the key. My bad. So you could just go ahead and use this from the for loop. But what I like doing is, since I have the key, I can manually make the data without making an F input info. So I have the key that comes from the input action. And I brought it down over here. If I drag off of the key, I can get key display name. Okay? And that's this. And then if I right click on the input info parameter, I can split struct pin, and basically it'll let me set all the variables for this info right here on the spot. I won't have to change anything or make another input info to actually pass it along. So I can just pass in get key display name. It will automatically do this conversion for me and add this little middle node. That's perfectly fine. And then I can use get time seconds to pass along my timestamp. And then just make sure you drag the code flow into it, the white line. And when you get into the function, it's going to be a full input info, so you don't have to create it here either. So that's very useful. It actually saves you some memory and will help your performance as well, because you don't have to make structures every time. All right. And now what we want to do, and this function is very simple. We just want to add the input that we have to our input buffer. So our F input info is what we passed along. We take our input buffer, we drag off of this and type add, and then we pass along the parameter. Okay, that's easy enough. And then we're going to call our check input buffer for command. So if you have not made that already, go ahead and make that now. Now this doesn't have any parameters to it. This is basically just checking everything in our input buffer against all the commands. We need to know what commands we pressed or we matched, if any. So we're going to have to loop through all of them. So we have our command list here, and this next part is going to be the most complex part of the whole episode. There's a lot going on here, so I will explain it all. If we can do this, then the rest of it will be very short and very simple. So here's the start of our function, check input buffer for command. Now what we need to do is we need to loop through all of these and all of our commands, and we need to grab each command one by one and then compare the individual inputs of that command to our individual inputs of our input buffer, see if they're in the right order, and if we have the correct number of matches in the right order. So say the command is 3 commands long. We could get 2 in a row, but we don't want to perform the command yet. We want to make sure that we get 3 in a row to perform the actual command that has 3 inputs. So we have to loop through the command list, check the inputs against each command, and make sure that we get the correct number of inputs right in a row. If we do, then we can go ahead and use our command. So grab your command list, just bring it on, hit get, and then we're going to loop through it. I didn't show you this before, but just type for each loop, and that's how you can loop through them. And we're going to break it again. Drag off array element and type break. It will give you all the different variables within the command, which are name, inputs, and has used commands. So the array that we have in the command itself is the inputs array. So let's loop through the inputs. So drag off of this and type for each loop. So see how this works? We have our list of commands. We're looping through them one by one. So command 1, command 2, it would technically be command 0, command 1, and then we're looping through the inputs of that command. So if command 0 is Z and X, then right now we're index 0 of this for each loop at input 0, which is Z. Okay, that's what the array element is here. This is actually Z on the very first pass. And now we need to compare this value to what's in our input buffer. So grab your input buffer, type get, put it here, and we're going to do a for each loop with break. We do it with the break so that we can cancel out if we find a match, or really just whenever we match this key with the key that we need in the command list, because we don't want to keep looping. Like, if there's multiple commands that start with Z, and we found a Z, we know that those are the commands that we need to look for. Okay, so we do a for each loop with break, and the break is a little weird, so you don't have to do anything with this yet, but just make sure it's with break. You can always change it later in case you do a regular for each loop. We now need to add something called a local variable. You'll see local variables whenever you're within a function, and basically they're variables that only work inside this function. It's good for memory. You know, you don't have to keep track of all these other things in too many places, and you don't need to have variables that aren't going to be useful for you outside of these functions. So just press local variable. It's down here at the bottom. I called mine correct sequence counter, and it is an integer. Okay. And what we're doing here is, this is the correct sequence counter. This is how we determine if we've matched enough inputs in a row. Like if we've actually performed the command, if we've pressed enough correct inputs in a row for that command. So this is very useful. And it's going to be 0 by default. I have not changed that. So here's how this is going to work. In our input buffer, we're going to grab our array index. Okay, and we're going to add the correct sequence counter to it. And we're going to make sure that that is less than the length of the input buffer. Okay, see how this is working? Array index, integer plus integer, add the correct sequence counter. Make sure that it is less than the length of the input buffer. And then we have a branch that determines what we do after that. So let's go over this so we understand what's happening here. And I might need to pull up like Paint or something to kind of show you. But we have our input buffer. So let's pull up Paint. Okay, so Paint. Here we go. I'm going to try and make it to where it's not blocking the screen so you can see it. I also want you to understand what's going on here. So we have our input buffer. Say the user has pressed Z and Y, which remember our commands are Z and X and A, B, Z. So we're looping through the input buffer. So at the first pass of at the first loop, we start at Z here. Okay. Now we grab the array index of this loop, and we add the correct sequence counter, which we've never added to the correct sequence counter yet. So this is 0. So we say 0 plus 0 is 0. We check if that's less than the input buffer length. That way we don't get an out of bounds error and crash. That's why we're checking against the length here. We just want to make sure we won't crash, we won't go out of the array. So we're at 0. The input buffer has a length of 2. It's got Z and Y. So this is going to return true. Okay? This is going to return true that this is less than the length of the input buffer. If it were to return false, it would set the correct sequence counter back to 0. This does two things. This will stop it from crashing, and it will also say, at this point, we have either gone too far, you know, we pressed too many commands, and it doesn't line up with the command list the way we want it to. It could also mean we have pressed not enough commands, or at least not enough correct commands within the input buffer. So say the first command is Z and X. But if I pressed ZCX or CZX within that time, then maybe that's a different command or it's a wrong command for this moment. And because of that, we want to reset the correct sequence counter. This is not a good time to continue. But otherwise, if this is true, which it is in this case, we have two inputs, so 0 is not out of bounds and Z is going to be a match. We're going to compare the actual the input name of the input buffer to the input name of the array element. So remember, we're looping through all the elements of that specific command, and my commands are Z and X. So to make this clear, this is the input buffer, and then this is the command I'm trying to perform. Okay? Now, we're going to use this index, the array index plus correct sequence counter. I used it to check to make sure it's less than the length of the array, but I've also brought it down here, and I've used it right here. So I do input buffer get, and you can get a reference. A reference basically will make the changes or look at the value right on the reference, you know, the actual data of the input buffer. A copy will copy the data over so you can edit it and look at it in a copy, in a temporary version. You can get a reference here. To be honest, you actually don't need a reference. You could use a copy because we're not changing it. But either way is fine. Okay, so we do get with that array index, and then we break it, and then we grab the input name. So we grab the key, basically. So in this, what we're checking here is Z. We're checking Z here. And we're checking if that is equal to this array element. This is the input array first index, basically. So the first index of the first command list input array. So first command, first input is going to be ZX. My other one, just for show, is A, B, C. Okay? So these are our two commands. We see that the input buffer, first index of the input buffer, does match the first index of the first command and the first input in there. So this is going to return true. Okay? So we do a branch, and if it's true, we continue on this logic. But if it's false, we say 0. Basically, here, we're setting it to 0 because we're saying we pressed the wrong input. Whether it's the right number of inputs, or we don't have enough inputs yet, it doesn't matter. We pressed the wrong input, so our sequence is broken. We can no longer continue like we should. Now, for this first one, this is not true. We did press the correct inputs, so we're going to continue along the true path. We're going to increment correct sequence counter. Increment is basically adding 1 to a value and then setting it back to that value. So the way you do this is you can drag off an integer and do increment int. Okay, and then you'll get this node, and this will add 1 to whatever value you put in and then return the new value. So if correct sequence counter is 0, we add 1 to it, it returns 1. And then this variable itself actually changes. So this variable is now 1. It didn't just add it and then return that. It actually updated this variable that we passed into it. All right. And now, with correct sequence counter being 1, we check and see if that value is equal to the length of the command input array. So remember, our first command here is only 2 inputs long, Z and X. So we want to see if we've gotten the correct number of inputs right in a row, if we've gotten the correct sequence of inputs. We have 1 correct, and the length of the inputs array is 2, Z and X. So this will return false. We don't yet have enough inputs. It doesn't mean that we are not going to perform the command, but we're not ready to perform it yet. So this is a little bit weird. Don't worry, you don't have to set yours up like this. Basically, we need to bring the false back to the break on this for each loop with break that I mentioned earlier. The reason it looks like this is because I tried to bring it around for you guys, that way you could see it in a nicer way. But it's a little ugly. Basically, it goes up to this node, then to this node, then to this node, which brings it all the way back here, which brings it back into the break. Breaks are weird in Blueprint. Usually you could add like a custom event or something, but we're in a function. So without getting too complicated, the point is just you need to bring it back into this break. We don't want to perform any of the other logic right now, but we do want to continue and go to the next part of the loop. So once you've broken this, it will break out of this loop cycle. Okay, it will no longer be performing this loop, which is good because we've already found a match for our first command. We found Z. We now want to find a match for the next input in our command, which, again, in the command list, we have Z and we have X. So now that we found Z, good. We want to check the input, okay, the next input that we added to the next input that the command list has, which is X in this case. So remember, our correct sequence counter is still 1. We're going to grab our, it's going to go to the next input. So it's going to go to X. We're going to start this over again. We're going to go to for each loop with break. We're going to grab the array index, which is 0 in this case, but we're going to add the correct sequence counter to it, which is 1. We're going to make sure that 1 is still less than the length of the input buffer. The length of the input buffer is 2, so we are still solid. And then we are going to branch. And only if this is true, we continue. Remember, we don't want to fail out at this point. We're still doing everything correctly. Then we're going to grab the input buffer value at this index. The index is now 1 because correct sequence counter is 1. So we are grabbing Y in this case. We break that and get the input name, and we compare Y to the array element of the next iteration of the loop. Since we already did Z, we now moved on to the next iteration, and we moved on to X. But Y is not equal to X. Okay, so this returns false, and our correct sequence counter resets. We added a wrong input to perform this command. Alright, so that's a failing scenario, if that's how that works. Let's go over a scenario really quickly where we get it correctly. So let's say this is ZX. Okay, so imagine this is ZX and ZX. I know it's a little funny looking, but these are supposed to be ZX. So we already went over the logic to get Z correctly, so we'll just go over the X logic. Let's pretend we never had ZY and we always had ZX, and our command was always ZX. So remember, we went to the next index in this inputs array. So now we're on index 1, which is X, in this command. And it shows you right here, by the way. It shows you the index. So index 0 is Z, index 1 is X. So we're on index 1, which is X, and now we have to loop through our input buffer and see if it's the same. We loop through the input buffer. Our correct sequence counter is 1. We already got Z correct, so we incremented the correct sequence counter, and it's 1. 0 plus 1 is less than the length of the input buffer, which is 2. So we continue along here. Then we use the input buffer and get the value at index 1. Remember, array start at 0, so index 0 was Z, index 1 is X. So in this case, we're going to break the F input info, check the name. We say, is X equal to X? That's what this is. And they are, in fact, equal. So we're going to increment the correct sequence counter again. And since it's going to be incremented again, it's going to go from 1 to 2, and correct sequence counter will be 2. Now, is 2 equal to the length of this inputs array for this command? Yes, it is. So the command list, it only has Z and X in there. It's got 2 array elements. It's got a length of 2. We've got 2 correct elements in a row. 2 is equal to 2. So now in the branch we go to true. We can start the command. And then I go ahead and break the logic anyway. I bring it to the same nodes that I did before, which goes and breaks this. And this is because technically our input buffer system right now will continuously check all the logic. So it'll keep going through and see if there's other commands that it matches. This isn't really what we should do, so we'll have to update that. But it's okay for now. That only will become a problem if you have multiple inputs with the same order, but you want to be able to perform one and not the other. So the start command function. Now, if you didn't make it, go ahead and make a new function now. Call it start command. And then we want to add a parameter to this one. Again, click on the function there or click into it. On the details panel, you have an inputs. I've added a command name and a string. So I've called this command name and I've made it a string type. So command name basically is the name of the command that we want to execute. And that's really for 2 reasons. It's one, so I can check against it to determine which one we can set to be true. That way we know which one to actually activate. But it's also to print it out for us for debugging reasons, so we know which command the user is trying to use, or the character in this case is using. So once you've added this input parameter, then what we pass along is this line right here, which is the name of the command from the inputs array. Remember, we were using this inputs array, we weren't using the name. Well, now we're going to be using the name and bringing it along into the command name here. Okay, and then we're done with this function. Now the last thing we need to do in here is the start command function. So start command is not very complex. It might look a little bit complex, but it's really not. It's really the same stuff we already just did. I'm just doing it again to be triple sure, really double sure, that we are performing the right command. You could skip a little bit of this if you wanted, but I just like I kind of like the safety net here because there's so many things that could go wrong with the command input, the command buffer, and the input buffer. So in start command, I grab my command list and I loop through them. I see if I can find the one with a name that is equal to the name that we passed in. And when that is true, then I'm gonna set the hasUseCommand variable to be true for that value. Now this is a little bit strange, but remember I was just talking earlier about copies and references when you're getting a value, like how I said, oh, it doesn't really matter what you get here because we were just, utilizing the information. Now we're going to be setting information in here. So we have to make sure we get a reference. We can't use the array element from the for each loop. So let's go over this a little bit more slowly and do it with this in mind. So we grab the command list and we loop through them. We check each command's name against the command that passed in. When we find a match, we grab the command list and get at that array index. We know, since the names matched, that this is the command that the user was trying to use. Or whether they were trying or not, this is the command that they did end up using and their inputs match with. So we grab that array index and we command list, we do get, and make sure you get a reference here. If you get a copy, it will not work. Get a reference here because we're going to set variables in this. Alright, and again, since this is true, we go to this logic, set members and fcommand info. So this node is also a little weird. So drag off the get and type set members. And this is how you set, different variables within your structure. But when you initially get it, it looks like this. It has your struct ref and your struct out. So it has the structure that you're passing in and what the new structure is. But you don't have any variables to set here. Now you can look in your details panel and set as pin to add them. Make sure you only add ones that you are changing or that you are okay with being reset. If you add them as a pin and then don't put anything into them, they will be reset to their default values. I only want to change the hasUseCommand, so I'm going to only have the hasUseCommand as pin here. I'm going to force it to be true. Right now, and really for no reason I can think of, would I ever want to set it to be false if we perform the command. There's other places we want it to be set to false, but when we're performing the command here, I always want it to be true. So I just force it to be true. Then lastly, as a debugging technique, I add a print string and I drag the name of the command into it. That way we can see what command we're using. Alright, and at this point your command should be good. There are a few things we need to do to make sure you can actually see it, like if you want to play an animation, and I'll cover that because it should only take us a minute. So for those familiar with the Action RPG tutorial series, I did have some layered blend stuff going on. I took it off for this episode, that way we can kind of just focus on the animations. So don't worry, nothing's going away, but I just disconnected it, so there's no need for any confusion. Basically, in our default state machine, I've added a state, right-click, add state, and I called it special move 1. I've given it this animation, which is specifically like a healing animation off of Mixamo. If you want to know how to add animations to your models on Mixamo.com, then I'll leave a link in this iCard right here. Not going to be getting in that today. Alright. I made sure it doesn't loop because we want to set the variable to be false after we've used it to say we are no longer using the command. So it does not loop, and then I can get there from idle and idle alone. So idle to special move 1, I have this logic here where I only enter this state if the command, has used command, is true. Now, I have no problem hard coding here because, you know, every command should be bound to a specific animation or a specific action. Since we know what this is ahead of time, we also know what value it is in the command list. You could tag them and do different things to make sure it's always valid, but really, this is something that can be easily kept track of. I don't think it's necessary, at least not right now. If it gets more complex, maybe we will want to. You can grab the character reference that we have in our animation blueprint. Again, for those that are following the Action RPG tutorial series and looking at this now, I did have to make one minor change. I was casting to the code class before. Since we're doing a blueprint-only input system, if we want to be able to access the blueprint system without doing a cast before the node, we can cast to the base character BP in the begin play and blueprint update animation to get a reference. And for those not familiar with this series, this is all you really need to know about what I'm doing here. Try get pawn owner, and on blueprint update animation and begin play, try and cast the base character BP, or the character that we just did all that logic in, and then set a reference to it. You can drag off of the cast and hit promote to variable if you don't want to go and find the type. Now we have this character reference. We can go into our idle to special move 1, drag the character reference onto the screen. Now we can get our command list, which is the variable we made and filled out. And then we can get a reference or a copy. Again, it doesn't really matter in this case since we're just getting it. Really, you should... it doesn't really matter in this case. So we're going to right-click and hit Split Struct Pin. And then you can see all the values of it. We're leaving it index 0 for now. And we do result. And we plug in the has used command to the result. That's how I've done the idle to special move. And I don't have any transition events or anything like that. Now, for special move 1 back to idle, I do have a transition event, but my actual transition rule is empty. I've made it automatic. So basically, once the animation is done, it will return back to idle. Now the rule I've called end command, and I put it on the start transition. So once this knows that it's returning back to idle, and which is basically once the animation is finished, this event will get called. You just type in any name you want here, and then when you go into your event graph, you can type in that name, which mine was end command, and it will come up. You want the event anim notify, and it will come up right here. So the last thing we're going to do is reset our has used command back to false once the animation is complete. You could actually do it earlier, like right away as soon as we trigger the animation, but it doesn't really matter. It will depend on your game, perhaps, to, you know, if there's different complexities or different ways to cancel out of it. In this, I grab my character reference, I grab my command list, and I grab the length. Now, I'm going to basically be looping through the command list and setting all of these back to false. You know, again, this may or may not be what you want to do depending on your game, so feel free to change it to fit what you're working on. If you are doing it this way, then if you grab length, make sure you subtract 1 before putting it into the last index of a for loop. This is a regular for loop, by the way, not a for each loop, so you just do for loop, and it's the one under flow control. Now, for loops start at an index of 0, but length is the actual number of items in the array. So if you were to just pass length into last index, you would get a crash. Make sure you, if you grab length of the command list, you subtract 1, integer minus integer, and then take the return node and pass that into last index. Then I grab the index of the loop, and then I get the command list at that value. So command list get, again, reference or copy, either way. Actually, no, sorry. Do a reference on this one because we're setting a member in the command info. So make sure this one is a reference. So get a ref. Pass in the index. And then we're doing the same thing we did before where we set members. And then we have has used command as a pin. And then make sure you're setting it to false this time. And then it will be reset to default. That way they have to press the inputs again to be able to perform the action. ZX, and then when it's done, I can live my life again. But if I press ZX, it happens again. And then same with ABC. I press ABC, and it says Command 2 in the top left. I don't have anything bound to this, so it won't actually do anything. But you can see that it is registering that I am using the command, so you can fill out whatever logic you wanted. Alright guys, so that is the blueprint-only input system. Now, a few notes on this. So, like I said, I will be doing some additions to this to kind of update it for the specific questions I've gotten. I've gotten questions about, like I said, a radial menu, a bunch of click events, release events, binding them to events, and being able to put as many inputs in and change them in real time. There's so many things we can do with this. So I'm going to have plenty more episodes on this. And now that we got the first one out the door, I'll be working on more. Probably once a month or so, there'll be an episode on this. I really like input systems, so I have no problem doing the code and blueprint version and then just the blueprint version. Just don't get confused. You do not need both. You need one or the other. So you can choose. You can watch them both and choose if you'd like. Anyway, guys, thank you so much for watching. I'm Shawnthebro. If this video helped you, please subscribe. It does more for me and more for the channel than anything else you can do, and it just lets me know that you enjoyed this video and that I did a good job teaching you guys what you wanted to learn. If you had any issues with this tutorial or any of my tutorials, feel free to join the Discord community. We'll be happy to help you with any of the issues you had with the tutorials, or if there was something I said that didn't make sense, or even if I forgot something. Sometimes I forget something in the video, and I apologize for that. But if you do come forward and talk in the Discord, I'll get it fixed up so that other people don't have that issue. If you want to come support us on Twitch, twitch.tv/Shawnthebro27. We just play video games. We've been playing Bloodborne and different things like that. We've played all the Souls games except Bloodborne and Sekiro, at least all the ones from Software. And yeah, we do some programming streams on there. Mainly it's going to be on YouTube now, but every so often I still do a programming stream on Twitch. So if you want to check those out, feel free to. Otherwise, just check out every Friday right here on this channel. You can check out a live stream 6 to 8 p.m. Eastern Standard Time where we work on a side-scroller game. And I want to give a huge shout out to all my Patreon supporters. Guys, thank you so much for the love and support, for real. I really, really appreciate it, and that support really helps me continue working on these videos. And all these special videos like blueprint only and different crazy videos that I didn't think I'd really be doing, but I actually end up having a really good time with. So thanks for the support and love, guys, and just thank you so much for everything you've done. I'm Shawnthebro, and I will see you in the next one. Goodbye, guys.